This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Welcome to Dr. Tarazi's math site. Statistics and probability is an important domain. 11 to 12 questions out of 48 are on the test. Summarize and describe distributions representing one population and draw informal comparisons between two populations. Standard 7.SP.3. Please pause the video and read the description of this standard.
Hello and welcome. Here is what you need to know before we get to the examples.
What is a dot plot?
A dot plot is a graph using dots to represent the number of data points along a number line. And usually dot plots are used for small data sets. If 17 students were asked were asked how many books they read during the summer break. Okay, so now we make a number line here. That's the number of books read. So, and then you tally your answers from these 17 students, and you get something like that. What does that mean? If I look at this, that means one student only read 9 books. 4 students read 6 books. No one read 3 books, or 7 or 8. Okay, so this is called cluster. This is called cluster. This one here is called represent an outlier. It's like way away. It's away from the average here. Okay, very far away. Now, if with this here, your really data set is this: 1, 1, 1, 1, 1, 5 times, 2, 2, 2, 3 times, 4, etc. From this here, you can calculate the mode, the median, the mean, and the range. So the mode is 1. This is the mode. 1 is the mode. There's 5 of them. That's sometimes called the peak. The median is 4. There's 8 to the right and 8 to the left. If you calculate the mean, you find it to be 4 as well. The range is 8. 9 minus 1 is 8.
Recommendation.
To make the most of these videos, I suggest pausing the video when you see this button, solving the problem, and then resuming the video to check your answer.
Example 1.
In this example, you have 2 box plots, excuse me, and I have a video about this topic, box plot. I would recommend that you watch it. So we have here 2 box plots, this here and this here. That's for data set X and that's for data set Y. Remember, this is the median. This is the third quartile. This is the first quartile. This is the minimum. This is the maximum. From here to here is the interquartile range. This minus this. The range is the maximum minus the minimum. So which statement correctly compares the data sets? First, the medians of both data sets are the same. Is this the same as this? No, this is 15 and this is 13, so you just cross this one as not a good. The second one, the interquartile ranges of both data sets are the same. Now you need to do some calculation. So for the interquartile for X is this number here, 16 and a half minus 13, you get 3.5. The second one is 14 and a half minus 11, you get 3.5. They're the same, so you got the answer. Now, if you want to check the others here, options, the range of data set X is greater than the range of data set Y. If I calculate the range of data set X is 18 minus 11 is 7. For Y is 17 minus 10 is 7. So they're the same, so that's not correct either. Okay, so you cross this. Now the last one, the median of data set Y is greater than the median of data set X. Is this one greater than this? No. So you cross that too. Okay?
Example 2.
A group of students plan to participate in a swimming competition. The students begin training with a coach 1 month prior to the competition. The dot plots shown represent the time they took to finish a 50-meter lap before the start of training and after training was completed. So this is before and this is after. How do we understand this? That means there is 2 students, it took them 48 seconds. There's 2 students, 56 seconds. There's 1 student, 62 seconds, okay? Now, this is the results after training. And they're asking you to complete this statement here. A, small or large options for you. Overlap between the distributions indicates that after 1 month of training, there is a, you choose one of these 3 here, okay? So what I did is I took this graph and put it here. And you see now there is not that many overlaps. There is only 1 here, okay? And there's nothing here, okay? There's only 1. So, and you see all these numbers went smaller, went decreased, okay? So it's a small overlap between the distributions indicate that after 1 month of training, there is a significant decrease. Significant decrease. See, some of them, they finish it in 38 seconds.
Example 3.
Jerry grows 2 different types of oranges. He wants to know which type of orange weighs more. He takes a random sample of oranges from each type of tree and creates a dot plots shown with their weights in ounces. So there's 10 here, 10 here. So that's type A, that's type B. Let's see that we're comparing these 2, okay? Based on these data, which statement is true? First, it is certain, that means 100%, okay, that a type B orange weighs more than a type A orange. Is this certain? No, because there's a 14 here, okay? There's a 14 here, so that's not true. It's not certain, it's not 100%, okay? But if you look at the number B, there is evidence that a type B orange typically weighs more than a type A. So I'm like to do the mean of both of A and B. I get 10 here, I get 11.1. So the mean for the second one is here, okay? And the mean for the first one is right here, okay? So obviously this mean is larger than this. This is larger than this, okay? Also, the variance of B is less, see, it's most of the data is close to the mean, less than this, okay? So that tells me that there is evidence that a type B orange typically weighs more than a type A orange. Now, if you look at the other 2 here, you will see they don't make much sense. There is no evidence. No, you cross that. The mean absolute deviation of the sample is less for type A orange than for type B orange. No, the deviation here is more than the deviation here. So these, both of them are not good, okay?
Example 4.
Which 2 data sets show the most overlap? If you look at this here, you have 1 here and 1 here. You have 2, okay? You have 2 here. Now here, you have 1, 2, 3, 4, you have 5. Here, you have 1, 2, 3, 4, 5, 6. You have 6 here. Here, the last one, if I can find my thing here, what happened to it? All right. Okay, the last one you have 1, 2, 3, 4, 5, 6, 7. What happened to my... Okay. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9. So the answer is this. Okay?
Thank you and see you soon.
Thank you for watching. More videos to come. Please subscribe.